We are in lecture 2B of power electronics. Previous lecture we focused on power diodes, its characteristics. Let us take the discussion forward and talk about the diode classification and the various types. So ideally, the diodes should possess zero reverse recovery time. So we have seen in the previous lecture that the reverse recovery time plays a very important role in the switching characteristic of the diodes. This reverse recovery time, if it is zero, then the diodes will have a very fast switching speed, because all the charges which are stored in the reverse bias junction will be equal to zero, and this may escalate the manufacturing cost, which is again one of the limitations of the manufacturing of the power diodes. The diodes are generally classified based on the turn-off times. So turn-off time is directly related to the reverse recovery time. The reverse recovery time is a measure of the speed at which the diode can switch, that is the turn-off, and therefore gives an indication on the external switching frequency that may be used. If the reverse recovery time is less, then the switching speed will be high. So we require to manufacture such type of diodes where the reverse recovery time is very less. Based on this, the diodes are generally classified as the rectifier diodes, where the reverse recovery time is in the microsecond range, whereas the fast recovery diodes generally have the reverse recovery time in the range 200 to 500 nanosecond. The ultra fast recovery diodes will have the reverse recovery time from 30 to 200 nanosecond, and the Schottky diodes, which are basically the metal-semiconductor junction diodes, will have the reverse recovery time less than 30 nanosecond. So these classification of the diodes generally comes from the reverse recovery time and how fast the diodes can behave, and which is directly related to the manufacturing cost. The first category, when we talk about the general purpose diodes, their reverse recovery time typically falls in the range of microsecond, which is 25 microsecond, and they are used in low speed applications where the recovery time is not that critical. Example, the diode rectifiers and converters for low input frequency up to 1 kHz applications and line commutated converters. So such type of applications where you do not care about the speed, in such applications we prefer general purpose diodes, and they are some examples we have discussed, that is the diode rectifier or the line commuted converters. Their current ratings generally from less than 1 ampere to several thousands of ampere, and the voltage rating lies between 50 volt to around 5 kilovolt. Manufacturing cost is involved, generally manufactured by the diffusion process, and it is used in welding power supplies. When we talk about the cost effectiveness and ruggedness, alloy types are most cost effective and rugged. So in order to reduce the reverse recovery time, the cost will increase. So here the reverse recovery time we don't care, so it is cost effective. The rating of these alloy type can go up to 1500 volt and 400 ampere. So such type of applications where we do not care for the reverse recovery time and the current may be as high as 400 ampere and voltage as high as 1500 volt, we can prefer general purpose diodes. These are some of the pictorial representation of the general purpose diodes which are available in the market, used in the laboratory and the industries. When we talk about the fast recovery diodes, normally these diodes reverse recovery time is less than 5 microseconds. They are used in applications such as DC to DC converters or DC to AC converters where recovery speed is critical. So here the reverse recovery speed is critical. Now, if we talk about the current rating, it is less than 1 ampere and voltage from 50 volt to around 3 kilovolt. Manufacturing for high voltage rating above 400 volt generally is made by diffusion process and their reverse time controlled by platinum or gold diffusion. So this is the manufacturing process by which we can achieve a voltage above 400 volt. When you require to manufacture for the applications whose voltage rating is less than 400 volt, then we go with epitaxial diodes, provides faster switching speed and have a narrow base width, resulting in reverse recovery time as low as 50 nanosecond. So these fast recovery diodes are such type of diodes where we take care of the reverse recovery time, which is much more critical. When the Schottky diodes we think of, it is achieved by setting up a barrier potential with a metal semiconductor contact. So the elimination of the charge storage problem, which is generally take place in the depletion region, is generally achieved by setting the barrier potential with a metal semiconductor contact. When the rectifying action we talk about, it depends on the majority carriers only, minimizing the excess minority carriers and the recombination process. Recovery effect, if we talk, due solely to the self-capacitance of the semiconductor junction. The recovered charge much less than that of the equivalent PN junction diode. So first diode that we talked about is the general purpose diode, and here the recovered charge is much less. If we talk about the dependence on the reverse di by dt, that is the change of the current with respect to time t, largely independent due to junction capacitance. So there is a junction capacitance, so it is independent. Forward voltage drop is relatively low and the leakage current is higher than that of the normal PN junction diode. It is inversely proportional to the conduction voltage. When we talk about the maximum allowable voltage and the current rating, generally they are limited to 100 volt and the current in the range 1 to 400 ampere. Their ideal applications are high current, low voltage DC power supplies. So depending upon where we are using the diodes, we can prefer different types of diodes having different reverse recovery time. The diode parameters, if we talk, then various parameters are there in the data sheets of the diode, which are crucial for selecting the right diode for a particular specific applications. These parameters beforehand is essential to calculate so that you can achieve a proper functionality and the reliability. Now, what are those parameters? If there are numerous such parameters, like for example, if we talk about the voltage drop under the forward bias junction or the region, then the voltage drop across the diode when the forward biasing occurs. So forward biasing and reverse biasing we have discussed in the previous lecture. The reverse leakage current, that is the current in the reverse direction when the diode is reverse biased. So we should have a proper knowledge of this leakage current and the voltage drop. We should have a knowledge of maximum forward current that the diode can handle in the forward direction. What about the peak forward surge current? So when we talk about the surge, it is basically the transient condition, and when we talk about the peak, it is the maximum current that the diode can withstand for very short duration of the time. The reverse voltage, that is the maximum voltage the diode can withstand in the reverse bias without breakdown. Reverse recovery time we have discussed in very detail in the previous lecture. That is the time taken by the diode to switch from the conduction to the forward direction to blocking in the reverse direction. This should be as low as possible. Power dissipation generally takes place in the diode because you have a voltage and the current, and this should not damage the diode due to heating effect. There are other factors like temperature coefficient, which is the rate of change of forward voltage with temperature, the junction capacitance, which is the capacitance across the diode junction, operating temperature range at which the diode generally operate efficiently, the packaging type, what type of packaging this diode has been done. There are different type of packaging process involved in the manufacturing. The reverse recovery charge, which is directly related with the TRR or the reverse recovery time, the total charge restored in the diode in the reverse recovery time. What is the forward voltage variation with current, change in the forward voltage drop with change in forward current. The reverse recovery energy, which is the energy dissipated during the reverse recovery. Some energy will be dissipated because all the charges are being taken off. The reverse breakdown voltage, which generally take place when you are supplying a voltage Vs which is much greater than the diode withstand capability. The diode may be of different type, whether it is standard, Schottky or Zener diode. So these all parameters will be written on the manufacturing data sheets, and we have to go through it without having a proper applications. So when we need the diode to be applied in certain applications, we should have a proper knowledge of these parameters. Now, when we talk about the sinusoidal quantities, whether it is a current or voltage, average RMS and maximum values are generally interrelated, which are well known. Like for example, suppose we need to determine the maximum value or the peak value or the RMS value of any sinusoidal functions, they are interrelated to each other and which are widely understood and known. However, this relationship does not hold for non-sinusoidal current. So when the current is non-sinusoidal, like for example, suppose the current is square wave or the current is triangular wave or the current may be any other non-sinusoidal function, then in such relationship, it is very difficult to calculate the average RMS or peak value, and they have to be calculated certainly using the specified current and voltage waveform for which the diodes are applied in the circuit. In high power circuit, it is crucial to ensure that the chosen diode rating exceeds the actual current in the circuit for reliable operation. So you have to check whether the high power circuit it is there. So you choose what type of diode you are using properly, and it should not exceed the actual current for which it is being applied. Detailed datasheets may present parameters using nomographs, providing another method for diode selection based on the graphical representations. So these nomograms are basically the graphical way of presenting the parameters, which are again present in the data sets of the diode in certain applications. So this is a very short lecture, theoretical in nature, where we discussed about the classification of the diodes. Previous lecture we have discussed about the diode characteristic. So we are coming up with the theoretical foundations on power diodes, and then we'll move to the switched RLC networks. Thank you for now. See you in the next lecture.